Welcome to this video on GenAI App with RAG on Cloud. Hi, I'm Karthik Ninghana. I'm currently an MLOps Engineer at Typewise. And in this video, we would be creating a GenAI chatbot. We'll power it with RAG and then deploy the whole application on cloud. So let's look at some of the key takeaways from this video. First, we would be creating a document analysis chatbot where we'd be giving it documents related to the market studies and we'd be asking it questions and would see how good it is in terms of extracting these reports and getting output from them. We will do a full end-to-end architecture walkthrough of the whole application. We'll also do a line-by-line code walkthrough where we'll look at each step-by-step process that happens in the code. And then we will also set up our AWS account and then deploy the application after containerizing it using multiple services in AWS. So what would be the major key takeaways? Number one is we'll be doing a RAG pipeline in AWS. So we'll use AWS Bedrock Knowledge Bases, both for document storage and retrieval. Then we would also create a chatbot agent with UI. So we are using for backend Python language, and we'd be using a framework called Llama Index. Also for the front end of the application, we'd also be using another Python package called Gradio. And finally, we will be deploying the application on cloud. So containerize the whole application and deploy it to AWS. So let's have a look at all these services that we will go throughout this whole application. First is S3 data storage. So S3 is one of the services in AWS where we can store files and then we can use it using different libraries to store and retrieve these file systems. So all the documents that we would be working with would be stored in S3. For the vector database, we will be using OpenSearch Vector DB. This is one of the services in AWS. For the whole RAG application, we would be using AWS Knowledge Bases. So instead of doing everything in Retrieval-Augmented Generation, also known as RAG ourselves, we'd be using one of these services in AWS called AWS Knowledge Base, which will do all these processes behind the scene for us. We'd be using AWS Titan embeddings. So to create these embeddings and convert them from text to these numerical format representation, we have multiple different embedding types. The embedding we would be using would be the default AWS Titan embeddings inside AWS. We'd be using Llama Index agent. So Llama Index is a library which is created in Python and which really helps us streamline and connect all these things together in a very easy fashion. For the LLM of choice, we'd be using OpenAI. We'd be using the Gradio package. This is what helps us to create front ends just by using Python. We don't have to rely on other libraries or frameworks such as React. We'd be using AWS ECR. So the whole application would be packaged into a Docker container, and that Docker container we would push to AWS ECR, which is a container registry. And finally, we would be using AWS App Runner. So there are multiple services in AWS to deploy these applications. One of the really easy and scalable solutions is called App Runner, where we simply take our container, give it to App Runner, and then mention all the different configuration parameters, and it will deploy the whole application for us. All right, let's have a look at the architecture diagram. So as you can see, the box over here represents AWS Cloud, inside which we have multiple services. We have ECR, where our Docker container is stored. We have App Runner. This is the service which takes the Docker container and then runs it. We have S3 bucket, where our documents are present. We have Titan embeddings, which takes the text and converts it into numerical format, which are known as embeddings. Then we have AWS OpenSearch, where all these embeddings are stored. And we can create and search these embeddings using different input text that we get. So for example, these embeddings would be there in the vector DB. And whenever we have a question, we will take that text, convert it into embeddings, and we can find out the nearest embeddings for that particular text. And what it does is we will get text which is closer in meaning to the already saved text in the vector store. So what kind of data would there be? Let's say we want to do market analysis of Amazon. So we are going to ingest an Amazon shareholder letter and we'd ask questions based on the documents inside it. Now the vector store would already be having all these text, and we would be able to, based on our question, get the similar documents from that text. And so all of this similarity matching and everything happens in a vector DB. And the vector DB for us is going to be AWS OpenSearch. Now, as we can see, the app runner also connects to something called parameter store. So to store sensitive data in AWS, we can use services like parameter store. The app runner also connects to knowledge bases. This is done to make sure that the whole process of RAG is abstracted away using knowledge bases. What it means is that knowledge base is going to do both the things for us. Number one is when we put any data in S3 bucket, it will take those documents, will get the text out of them, then chunk it into small pieces. Every chunk would then be called with Titan embeddings and converted to numerical format and would be saved in the vector DB. All of this happens automatically behind the scene. The second thing we can do is applications like the application deployed in App Runner can call this Amazon knowledge bases to actually extract some of the documents which are closest to our given question. So we will simply provide it the question, and knowledge bases would then call Titan embeddings to generate the numerical format, fetch the closest number of documents from OpenSearch, and then return us back those documents. So as we can see, all of this happens behind the scenes in AWS Bedrock. And so for us, we would simply be calling these services using a simple library called Boto3, which is the default Python library to talk to different Amazon services. All right. So this is the whole architecture. We also have IAM role, which gives it permission to be able to call knowledge bases and also to fetch API keys from parameter store. What kind of data would be storing? In parameter store, we will store the OpenAI API keys, but we can also obviously use it for other sensitive data storage. And finally, the users can connect to our application in App Runner using a given URL. That URL is then going to load the Gradio frontend that we have, and that frontend can be used to connect to the backend application. The backend server then, using the question asked by the user, fetch documents from knowledge bases, and then would also be calling OpenAI with the fetch documents and the question to generate the final answer. Once we have the final answer, it will also give it back to the user. So this is how all of this works end to end. Now let's log into the Amazon console, and in the AWS console, set some of the things up. Okay, now that I've logged into my AWS dashboard, there are two things I have to take care of. Number one is I have to make sure I'm in the Mumbai region. This is where this demo is tested, and all of the services that we would be using are available in the Mumbai region. The second thing is we would be generating AWS credentials. These credentials we would be using in our code, which would allow it to be able to connect to services in AWS. So to create credentials on top, we will have to go to security credentials and then access keys. So we'll create an access key. We'll click on CLI interface. We'll click confirm. Next. Give it a nice description and create the access key. Once we have this ready, we can download it. In the same way, we will also log into the OpenAI platform, which is platform.openai.com. In this, we would be generating our OpenAI API keys. So on top right, we have settings. If we click on it, on the left, we have API keys. Up here, we can click on generate new secret key. We can give it a nice name. And this is the API key. We'll also copy it. Once copied, we'll head on to our code. And this code could be downloaded from the description. We have our OpenAI API keys. Let's paste that up here. Now we can already see a .env.example file. We can simply copy it and rename it to a .env file. This is the file that we would be using throughout the application to actually fetch environment variables like this. So I have my API key. All right. Then I can see I also have to put my AWS account ID, access key ID, and secret access key. This is something that we just created. This is the access key. We'll paste it over here. Then we have a secret, which we'll paste over here. You have to make sure there's no spaces after the equals symbol. And then we have our account ID. So on top right, we can see the account ID over here. Click on it to copy, and we can simply paste it up here. So this is how we have created our .env file. And this .env file would be used by the application to access both AWS resources and at the same time OpenAI APIs. All right, now that we are done setting up our credentials, we would then start working on creating the AWS services. So we'll be working with the right side of the application, which is the whole RAG pipeline of both document ingestion and retrieval. And for that, we have multiple services that we provision. We have our S3 bucket where we'll upload the data. So let's start by creating the S3 bucket. I've logged into the dashboard. On the search, I'll put S3. I click on create bucket. We'll give it a nice name. Click on create bucket. It's already. We'll have to make sure that we name it with hyphens and not underscore. Finally, we click on create bucket and the bucket is now created. If I click on it, we can see that the bucket is empty. So we'll just fill it up with documents. So one of the document that I'm going to put into this is the Amazon shareholder letter, where all the details about Amazon as a company is mentioned. Then I would do question when string based on this document, just to check if RAG is working fine or not. All right, so we can download this. And once downloaded, we can click on upload, or we can also simply drag drop the files to upload them. So as you can see, the files are uploaded now. And in this bucket, we have one of the PDF files. We can also put a lot of different PDF files, and they would also automatically be used by the Bedrock service known as Knowledge Bases. And then all these embeddings would be automatically created. But for now, we are just putting one PDF file. All right, so our S3 is done. Let's go to creating the second thing, which is knowledge bases. So on the search, I would mention knowledge bases. We can see Amazon Bedrock feature knowledge bases. We'll click on it. Every time we just have to ensure that we are in the Mumbai region, just to make sure everything works. Otherwise, we might see errors in our application. All right, so we'll create a knowledge base. I will select the first option, which is knowledge base with vector store, which takes us up here. We can give it a nice name. Now, the knowledge base itself needs permission to access different services. And for that, it wants to create a service role. We can mention the data source type, which is Amazon S3. that is where all our documents are, but there are different source types that knowledge bases also supports from which it can fetch these documents and work with them. All right, click on next. Now, because we selected Amazon S3, it is asking where the documents are there in Amazon S3. So we'll just give it a nice name. We'll mention our S3 bucket, AV demo GenAI bucket. And we have another option called parsing strategy. So this is about how these documents, when converted after processing into text, should actually be split. And so we'd be using the default parser, and then we'd also be using the default chunking strategy. So the parsing of the documents would be done by default Amazon Bedrock service. The chunking strategy is about once the documents are parsed, how we'd like to break it into. So we'd be breaking these documents into 300 token in size, and then every chunk would then be given to embeddings to be created into numerical format. All right. So what embedding model we would be using to convert this text into numerical format? We'd be using one of the Amazon's default Titan embeddings, Titan text embeddings v2, and then vector store, which is finally where to store these embeddings. We'd be using one of the service, Amazon OpenSearch serverless. So Bedrock is going to create that as well for us. And simply click on next. We can review everything over here. And we'll click on create knowledge base. So this is going to take around 5 minutes to create multiple services. And knowledge base is now creating the OpenSearch vector database and would then also be creating multiple services at the back. And this is going to simplify our RAG processing really easy, because knowledge bases takes care of both putting these documents into OpenSearch, and also whenever we'll ask question, it will do all the embedding, all the searching, and would simply give us the final results. So we'll wait 5 minutes, or we'll wait until this is complete. All right, our knowledge base is finally ready. We can have a look at it. Now we'll go into data source. The S3 bucket that we connected haven't actually synced, which means there is data inside it, but nothing is actually created in terms of vector embeddings. So as we discussed, this knowledge base is going to create an OpenSearch vector DB. So let's have a look. We'll search OpenSearch. We're opening it in a new tab. On the left, we can click on collections, and we see there's a Bedrock knowledge base collection created. We click on it and indexes, we can see that the whole vector DB is empty, which means we have to sync these documents. And this is very easy in knowledge bases. So if you're in the knowledge base, in data source, we can select multiple data sources. In this one, we just have S3. We click on it and we simply have to click on sync. And now these documents are being fetched. So the PDF that we had is being fetched, converted into text using parser. The text is then split by the chunking strategy, which is 300 tokens each. Then Titan embeddings are called into every chunk. They are converted into numerical formats. And along with the numerical format and the text for which those numerical format is generated is then saved into AWS OpenSearch. So all of this process is happening at the back. This shows sync complete. Let's refresh the page. And as we can see that the sync history shows that the syncing was done at this time and it is complete. You can also go to the OpenSearch vector DB, and we can see that there is index and multiple documents which are present. All right. So this means that all of the right portion over here, which is for the RAG pipeline, is complete. The ingestion of documents is also done, and then we have a filled vector DB. We can now start using it into our application. So let's copy the knowledge base ID. So the knowledge base ID is not the name, but the ID that we can see in the dashboard. So if we click on our knowledge base, we have the knowledge base name and then the knowledge base ID. So I'll just copy the knowledge base ID over here. All right. So now I want to connect to this knowledge base and ask it questions so it can give me back some related relevant documents based on that question. So let's head on to our code, and in .env, we'll add this missing piece of knowledge base ID, which completes our .env file end to end. All right. Let's have a walkthrough throughout the code. We have our Docker ignore file. So we are using Docker to package everything, and Docker ignore just make sure that the cache files are not inside the Docker container. We have our .env file, which we just created from the .env.example. This file would be used throughout the application. We have our git ignore, in which a lot of files are not pushed to Git. For example, the .env doesn't get pushed. Then we have agent.py file. This is where the code for the LLM and the agent along with the RAG retriever is written. And then we have the app.py file. This is the main front-end file where we would be creating our UI, and we'd be running this app.py file as a server, which would take request and respond back. All right. In requirements.txt, we can find out all the packages that we would need. So Gradio is the front-end application framework by which simply in Python, we can just create these front-end interfaces. Then we have Boto3, which is by AWS a package. Using this, we can simply connect to services in AWS. So the knowledge base that we see here can simply be connected to using the Boto3 SDK. Then we have python.env. This is what we would be using to automatically load the .env file into our code. And then we have llama index into 3 different formats. So llama index actually, for stability, have broken down multiple modules into different packages of their own. So the core llama index is mentioned as llama index, and then we are installing additional packages for OpenAI, which we would be using as the LM and retriever Bedrock. So this is for the knowledge bases, which comes under the Bedrock umbrella of AWS. So the service itself is called AWS Bedrock Knowledge Bases, and that's the package name here, Retriever Bedrock. All right. So this is the whole file structure. Let's first start by actually running the application, and then we will have a look at the code in depth. So for that, I would make sure that I source the .env file. This is to ensure that it doesn't interfere with some other environment variables that might be present in our machine. Then let's create a new Python package, Python workspace by python -m -env. We'll activate it using source venv pin activate. Once activated, we will install our requirements.txt inside it. We'll wait until all of this is installed. All right, now that all the packages are installed, let's just first see the demo of the application. So just to make sure our virtual environment is activated, if not, we'll go to source venv bin activate, which can activate it again. Then to run it, we'll simply do python 3 app.py. So in app.py, in the main function, we can have a look that first we get the UI, and then we launch the application on port 8080. All right. Python3 app.py. The application is finally running. We'll see that it's running on port 8080 with a title on top, a message history box, a message box, and 2 buttons. Let's ask it some question where RAG would be used. So the total revenue growth year over year of Amazon. Let's ask this question up. What was the total revenue growth year over year? So the total growth was 11%, which is the right answer. So our chatbot is actually calling the knowledge bases with the question, what was the total revenue growth year over year? And then it created some of the chunk text, it gave it back. After converting the question in embeddings, it then called the OpenSearch vector DB and got some of the similar results. The result was then fed into OpenAI along with the question and also the history of all the messages. For example, how would we know the history of messages also passed to the LLM? We'll ask it something related to history. For example, multiply this number by 26. So now this number is actually 11. And how would it find? It can only find it if the history is also passed to the LLM. That's when it'll know that 11 was the number before, and we have to multiply this, which is 11, by 26. So we can see that it was able to find out the number 11, which means to the agent, we are also sending the history of the conversation, the question that we have at that moment. And also, we saw that it is able to use RAG to fetch some of the document chunks which are in the vector DB over here. And then a combination of all three, which is RAG, history, and the current message, it's able to generate replies. All right. So now let's have a look at the whole code base. We have the app.py file, which imports Gradio. And then we import another function called getAgentResponse. This comes from a file agent.py where all of the agent code is written. But for now, we'll just focus on the front end. We import the Gradio package using import Gradio. We then create the whole UI using this function called create Gradio interface. We can see that Gradio.blocks, we can mention the title. We can see the title chatbot with knowledge base. We then create Gradio markdown showing chatbot with knowledge base. Then we have history, which is this box over here, which we used to do all the conversations. And then we have the message, which is the text box that we created over here with the default text as ask me anything. We then did a little bit of CSS styling just to make sure the container and the whole application container is small enough and doesn't actually go through the whole window of the application. So just a little bit of CSS styling here. And finally, we create the submit button and clear button. Over here with the value sent and clear chat. Finally, we'll be creating two functions. One is user submit and one is call agent. Right. So when we click on the submit button, what we want to do is we have the message history over here. Whatever we'd be asking or we have already asked to the agent would be present up here. And we'd be asking another question in the ask me anything section, right? So we have to make sure that we add that particular question to the history and we update the history. So if there's no message and we simply click on send, in this case, just do nothing, just return empty with the same history that we got, right? And when it returns empty, the file up here or the value up here is also empty. And if there's something that we have written For example, what is the year-on-year growth of Amazon? Then when we click on send, we can see that in the history box, we have this question now. And why is it? Is because when we get a message, we append it to the history and we return the history back. And all of this history automatically gets shown in the history box. All right. Then we have another function called call agent. This function is called when the last message that we have was actually by the user. And so over here, we can see that the last message is now by the assistant. And so in that case, the agent should not be called. When we'll ask a question over here, that's when the history would be updated with the last message of the user. And then we'll enter into this code section where we will get the user message using the last message of the history because we updated the history up here. So the last message content will give us the user message. And how can we get the whole chat history? Simply by taking the history with all the messages except for the last message. And finally, we can use these two things to call our agent using getAgentResponse. We can see that we haven't mentioned the RAG application knowledge bases for all this. That's because this function internally has already attached the RAG application that we would see later. Finally, whatever response we'll get back from the assistant is also added to the history. And the moment we return the history, it also gets updated over here. So before we had this particular question up here as message, now it was added to history, and that's why we can see it in this box. Once we got the response back from the LLM, we again added it to the history and returned. What that does was also added that particular response from the LLM to the history, right? And so all of this happens on submit button click. So in Gradio, we actually update UI in this fashion where on submit button dot click, we will call the user submit button, right? With components message and history. And as you can see, we have it available inside. And this will actually refresh both the message and history. So because after message and history, we can see that the returned value was empty. That's why when we click on send, the return value of message becomes empty. And in history, we can see that in history, we always add the new set of messages. And that's why when the history gets updated, we can see that this particular box also gets updated. So this happens on submit button click. We then have the dot then function, which means after you have done this, do this. So the next thing that we do is we call the call agent function with the history, and we also update the history afterwards. So when we have the call agent function inside the history, we already have the latest user message appended. Right? And then using that, we finally call it, we get the response, which we add to the history, and then we return the history back. We then reload history just to make sure all of our changes is shown over here. That's how Gradio works. And using this, the whole chatbot UI is created. We finally return this UI interface that we have created. And then we go to the method called launch, and we launch it as a server. So this is for the UI section. Let's now have a deeper look as how the agent looks like. So for the whole agent, we have the agent.py file. We have Llama index that we are using, which is going to glue all these things together and generate responses for us. So a lot of the code is automatically abstracted using the Llama index library. So to load all of our .env variables up here, we can simply call the .env package. And just by calling load env, we have all the environment variables available. Then we import multiple functions and classes from the Llama index package. As you can see, Llama index already has a method for integrating the Amazon knowledge base as a retriever. And it wants to know the knowledge base ID, which it automatically gets from environment variable, which is already loaded. In the retrieval config, we can mention that for a given query, how many documents we need back. These are the document chunks. So for the PDF that we can see up here, 34 chunks were created. And if we want at least 3 chunks as the most similar responses to the question, we have set the number of results as 3. So this is a retriever, which by calling and giving a query can actually give us the responses back. And behind the scene, it automatically calls the Bedrock Knowledge Bases service. And how does it know which knowledge base Bedrock to call? That's where the ID comes in, which we copied and pasted over here. All right. We're also going to create the LLM, and the LLM it also would be created by the llama index function. And so this particular class, we can simply instantiate it, and we can give the model name as OpenAI model environment variable, which is the GPT 4.1. All right. Now to actually use this as an agent, the retriever part, we actually have to convert a retriever as a tool. So in agents, we give it additional functionality using multiple tools. So what we are going to do is we are going to create a React agent over here. And the part of asking questions to be able to retrieve more information, we can do it with the tool that we will attach to the agent. So let's convert the retriever, the knowledge-based retriever, into a tool. And to do it, we'd be using one of the llama function in build methods. So you can see the retriever is the query engine. And the name and description is going to help the LLM to find out if it should call this retriever or not, or in which condition it should call it. So we can see the description, a vector database of knowledge about companies and their financial data. Whenever it will find out that the query is relevant to companies and its financial data, it will then automatically call this particular tool. All right, let's create our agent. So we have React agent, we have the tools, and in this, finally, we attach the tools that we have. The LLM that would be powering the whole application is going to be OpenAI. And this is the system prompt that we are going to pass to the LLM to help it make the right decisions. So the system prompt given is you're a helpful AI assistant with access to a vector database of knowledge about companies and their financial data. This, the LLM also known as tools which is attached to it. When users ask questions about companies or their financial data, use the available tool to retrieve accurate information. Always provide clear and concise answers based on the retrieved information. You must use English language for your responses and provide the answer in a concise manner. So what happens is, once we ask a question which is related to financial data, it knows that it needs to call this tool. This tool then internally calls the Bedrock knowledge-based retriever. That actually gives 3 chunks of text from our PDF document. But that is still not the answer. It takes these 3 documents. It also knows the present message by the user. It also knows the conversation history. And using all 3, it then finally generates the final answer, which has to be concise and in one line, right? And for that, what we are using is we have wrapped all of this into a function called getAgentResponse. So how is this function called? We pass the message and the chat history, which is we pass the questions that is asked. What is Amazon's latest revenue? So this is the message and this is the conversation history. And you can see the answer is 638 billion. All right. So the message comes in, also the chat history. Now we take the chat history and we just convert it into the format that Llama Index wants. And we also take the user message and we just put it inside content and also convert it into the format that Llama Index wants. We finally call this async function using await agent.run. This is our agent. And then we supply it with the user message, the question that is asked now, and all the chat history, all the messages in the past, which are these messages. And this agent already has access to the knowledge base using one of the tools. So we don't have to mention it again. This agent automatically has access to the knowledge bases retriever tool. Finally, this is run, and the response that we get is returned back in this function. When we get the response, we can see in app.py file, we get the response, we add it to the history, and that's why the response itself comes into the history box. And this is how the whole application works end to end. All right. Now that we know how the application works and we have looked at the front end and the back end, it's now time to deploy the application. To deploy the app, we are going to first package it into a Docker container. Now, there are two things that we have to look at. One is the .env file. As we can see, the AWS credentials consist of the account ID, the access key ID, and the secret access. This is the credentials for my particular user in AWS. This application actually runs in App Runner, where we would be creating a separate role and giving it access to all these services. So it's a bad practice if I'm going to supply these .env variables inside my application, which is actually created just for me. And one of the good practice is to actually always use IAM roles and policies. And these are the application variables that I have to provide to my application. The default region, the Bedrock ID, the OpenAI API key, and the OpenAI model. All right. So what I do is I have to now create this as an end-to-end package. To create the package, we are using a Docker file. In the Docker file, we are working with one of the Python 3.11 Slim, which is the smaller base image for Python 3.11. We create a working directory at /app. We copy the requirements.txt, all the packages, and then we finally install all the package. Then in terms of code, we just copy the app.py and agent.py file. And we then simply run our function using Python app.py. So this Docker file can then help us to create the Docker container, and then we'll push it to the Docker container registry. So before we do, let's quickly have a look at the architecture. So as we can see, the Docker file would be helping us to create the Docker container. Then we'll finally push the Docker container up here. And the application would then be deployed in App Runner. App Runner would then pull the Docker container and run the app. But before that, before running it, it will also go to parameter store to get all the environment variables that it needs. It will also inject these environment variables, so these would be available to the application. Now, to be able to call all these services, currently it was using, the application in my local was using my AWS credentials, but now we would be attaching an IAM role to the App Runner. What this role does is gives it permission to connect to knowledge bases and also to parameter store to fetch environment variables. It connects to knowledge bases to obviously retrieve all the documents from a given query, and parameter store to get the OpenAI API key so that it can finally use that API key to call OpenAI. All right. So to finally start with the deployment part, which is the left side of the application architecture diagram, let's start with creating our ECR container. So we'll go to the dashboard. We'll mention ECR in search. This takes us to the ECR dashboard. Click on create, and we can give it a nice name. GenAI bot, and that's it. Click on create. Finally, it's created. We can see the push commands now. First, we have to log into this Docker registry to be able to push things. We'll go back to the code. Now we'll just make sure that source .env, we'll just call it again, just to make sure all the my user credentials are loaded so that it doesn't interfere with any other AWS credentials if they are on this machine. I'm logging into this registry. The login has succeeded. Finally, I'll build the image for GenAI bot using the build command. One thing that I would mention is that I would always append it with platform Linux x64. This is because my machine, a MacBook over here, it has ARM-based platform, and just to not interfere with that, the type of image this has to be is going to be x86, and that's why it's a good practice to simply mention that the platform should be Linux x86, and so that the Docker container is not created as an ARM-based image. All right. So I just write platform. Okay, it worked nicely. The build is done. I can finally tag it. I can then, all right, now the push is done. This container is now pushed to the AWS ECR. We can go to the dashboard, we can refresh it, and we can see that the image is pushed. Now that we have ECR in place, let's also go and set up parameter store. So on the search, we will mention parameter store. Here, we'll click on create parameter. We'll name our parameter OpenAI API key. We'll mention it as secure string, so it would be encrypted and stored in AWS. And in the value, we would be putting the .env value that we have, just to make sure we don't have any spaces anywhere. All right, so with this parameter is created. OpenAI API key. It's nice. Now that we have the parameter also stored in OpenAI API key, the value is stored in parameter store. We can finally use App Runner to deploy the application. So in search, we will go to App Runner. We just have to make sure we are in the Mumbai region. Let's deploy this application. We'll click on create an app service. Now we have to give it the container. The container is an ECR. So we select container registry, Amazon ECR, and we can mention the container registry that we have. So we mentioned the repository, GenAI bot, and the image is latest. So this is what would be pulled and run. Okay. So App Runner also wants access to actually be able to fetch this Docker container and run it. So this is for the App Runner service. And so we can say that you can create a new service role that you want to be able to pull then. You also have an option for manual or automatic. If you select automatic, then automatically when there's an update to the Docker image in the AWS registry, then a new version is automatically deployed. All right, click on next. Now, the name of the application, let's call it GenAI bot. In terms of CPU, let's give it 2 CPUs and 4 GB of RAM. Now is the section for environment variables. As you can see, the .env is the environment variables which the whole agent.py file used using the load.env. But in our Docker file, we never mentioned .env or not even .env.example, which means that all these variables are not present in App Runner currently. And we have to make sure that all these environment variables are present. So for the first 3, we don't want to push it as a best practice to the App Runner console because this is my personal credential. What we would be doing is we'll be creating an IAM role and attaching that to our App Runner service, and it will give us access to connect to parameter store in Amazon Knowledge Bases. For all the other environment variables, we would be creating them now. So we have AWS default region. We'll select as a plain text. This would be the environment variable name, and the value would be AB South 1. The other one is the Bedrock Knowledge Base ID. Third one is the OpenAI model. And the fourth one is a sensitive environment variable, which we don't want to show in the dashboard because this would always be visible in the dashboard of App Runner service. So we have to mention that we want to fetch it from the parameter store. That's where we created this environment variable, right? So we want to put this inside the machine, the Docker container VM, as this particular environment variable name and fetch it from the parameter store, where in parameter store also we mentioned it with OpenAI API keys. All right. So in this way, all of our 4 environment variables are set up. We can see that port 8080 is where our application also runs. If we go to app.py file, we see by default it runs on port 8080, which is fine then. We can go to auto scaling. This enables the application to automatically scale up and down based on the incoming number of concurrent users. So if there are 100 concurrent requests, then this is how it should scale up and down. We'd also be doing health check just to know if the application is running fine. If it would not, it will destroy the container, create new ones, and it will automatically route traffic based on which containers are healthy. And so for that, we'll keep the default values, and the health check method would be TCP, which is just to check if the container is running fine or not. It will simply see if there's a socket running on port 8080. If there would be, the health check would pass, which means our application is running fine. So if there's a code issue, our application would not run, which means the socket at port 8080 would also not be working, and the health check would fail, which means the application has some issues. And so it will not send new request to that particular container. All right. For security, now we are going to create an instance role. So we'll click on IAM role. So this is the role up here, which should have access to the parameter store and also to knowledge bases. So we click on the IAM console. Up here on the left, we can click on roles. We'll create a new role. We'll mention custom trust policy. And hereby, we'll mention the service name. That should be allowed to take the role and attach it to different Docker containers. Service name is App Runner. We'll click on next. Hereby we'll do SSM read-only access, which gives it access to parameter store where our OpenAI credentials are. And we also have to mention Bedrock full access, which has internally access to the knowledge base. So this gives our application also access to the knowledge base. All right, we'll give it a nice name. GenAI AV demo. All right, so this role is created. Let's click on refresh to fetch this new role. GenAI AV demo. Click on this, and that's it. For networking, we want to actually expose this application to the public, and that's why we'll select public endpoint. This will create a DNS address, which we can use to finally launch this application to the public, and this would be accessible outside as well. If we don't want it public and we want to use it inside AWS Cloud, we can also go for private endpoint as one of the type. All right, click on next, and we'll check if everything is fine. And we'll finally click on create and deploy. This is going to take some time. And let's have a look at how the dashboard looks like. So the first tab we have is logs. This is the App Runner event logs. So what is the whole App Runner service doing right now? This is the deployment logs, which is all the deployment that is done by App Runner. We can have a look over here. And this is going to be application logs. Once our application, the Docker container would be pulled and run, we can see the application logs over here. Then we have all the metrics that we can have a look at, which is how many requests have come in, how many are successful, failed, and what are the status to see the incoming traffic. You then also have configuration where we can have a look at all the configurations that we have specified. And as you can see, one of the environment variable which was sensitive is now coming from parameter store, and other plain text, we can directly see the values up here. Scaling parameters, health check, and all. In terms of security, the role GenAI AV demo, which is attached, which gives us access to different services. And this is how we have set up all the configuration. Now, this custom domain is where the application would be hosted. So we went to localhost 8080, but now we have to just go to this particular endpoint to see our application. All right. So now we can see that there are some logs which are generated, which is pulling image and successfully pulled our image from ECR. Now it would be taking this image and deploying it. Let's wait for some more time. All right. We can see that the ECR was pulled. It was deployed. Health check was done on port 8080. Health check was also successful. So the traffic is routed to the application. You can just click on refresh. You can see the deployment is done. The deployment completed successfully. Soon we'd also be seeing the application logs. All right, no application logs yet. Let's go to custom domains. And as we can see, the application which was on my local is now finally deployed in App Runner. Yeah. Let's see if this works fine. One of the questions we just grab from the past. This was the application which was running in my local. It's in chatbot. If I ask it the question now, what is the year-on-year growth of Amazon? It is able to successfully answer with 11. What was the revenue 10 years back? All right. So it is able to do as it was supposed to. The application is working fine. The application logs would be coming soon, but the application is finally deployed. We can see all these metrics up here. All right. So we have successfully deployed our application in App Runner using the IAM role. Once the container is pulled, we get the parameter store. The IAM role is also used to actually fetch the values from parameter store. Knowledge base is given access to where it takes the query and asks the questions, and finally calls OpenAI and then shows the final result to the user. All right. So this was the whole end-to-end application demo. Let's quickly look at how to do all the cleanup of what we have created right now. So we'll go ahead and delete our GenAI bot, for which you have to type delete. This then removes the App Runner service. You also have to now clean up our ECR. So for that, we'll go to ECR. The GenAI bot, we have to click on delete. All right. Then we also have to remove the parameter from parameter store. The IAM role doesn't actually cost us anything if it's there, so it's fine if we don't remove it. We also have to go to S3, which is also charged. First, we have to click on the bucket, then click on empty. Now that the bucket is empty, we can delete it. All right. So the bucket is also deleted. So you can see up here. Now we have to go to knowledge bases and then remove our knowledge base. So on the left, click on knowledge base, click on delete, confirm that you want to delete it. Now deleting the knowledge base actually doesn't delete the vector store. And so you have to also go to OpenSearch service. And then in collections on the left, select the collection and also click on delete. Confirm your deletion. If you want, you can also go to OpenAI API keys and remove the API keys so that they are not used again or doesn't actually get exposed somewhere else. All right. If we want, we can also go to our security credentials, and just to make sure no unauthorized access happens afterwards, we can go to access keys and we can also delete them. So deactivate. This ensures that even if the code gets leaked, the credentials are no longer valid, both for OpenAI and for AWS. All right. So this marks as the cleanup of the whole application once the demo is complete. That's it for this video. Thanks for watching.